NewSAT, Test 1, Section 4. We're going to tackle numbers 22 to number 30 in this video. So they give this big chart. The new SAT is full of all kinds of charts. And they ask questions about the chart. Which of the following is the best approximates the average rate of change in the annual budget from agricultural natural resources in Kansas from 2008 to 2010? The most important thing to keep in mind is the average rate of change is the slope. So you're just basically going to find the slope in the agricultural natural resources from 2008 to 2010. So these are the 2008, 2010 are your x values. These two are your y values. So we're going to subtract the y values. So we're going to do 488,106 minus 358,708, and that's going to be over 2010 minus 2008. And when we subtract these, of course, you can use your calculator for all these numbers. Fortunately, when we do that, that's our slope. So it's a change in y over the change of x, and that's going to end up being 64,699, which is close to $65,000 a year. Now, the next one is, of the following, which program's ratio of 2000 budget to 2010 budget is closest to the human resources program's ratio of its 2007 to 2010? So human resources, we want to find the ratio between them. So it's going to be, what I would do on this, I don't know if you did this, most of you got this one right. Actually, 6 of you missed this one. You're finding the ratio between 2007 and 2010. I would totally round these numbers. So this is 4 to 6. So the ratio is 4 to 6, or 2/3. It takes you too long to enter all those numbers into your calculator. So then you're going to go up and do the ratio of all of these. So this one would be, if I rounded 373,000, that would be 4 to 5. So this one would be 4 to 5. That's not the same as 2 to 3. This one would be 2, and this one would be 3. So this one would be 2 to 3. You would just make all these zeros, and you would get 2 to 3. And if you kept going, you can see that this is actually the answer, so it's going to be education. You can keep going. You're going to have 14 to 15, no. You're going to have 1,500 to 1,700, 1,800, no. And this would be 300,000 to 500,000, no. So you just round them and then compare the ratios. It's a lot faster. I did it both ways. It's way faster if you just round it and estimate. All right, next one. Nobody got this one right, so I might spend an extra minute on it. Which of the following is an equation of a circle in the xy plane with center 0, 4 and a radius with endpoints 4/3 and 5? Okay, you might not have ever covered this before, that's why. The equation of a circle is x minus, I'm going to go over here, h quantity squared plus y minus k quantity squared equals the radius squared. H and k stand for the center of the circle. That's the center. So if the center of the circle is 0, 4, our center is 0, 4. So let's just plug our h and k in. This is an equation, I want you to write this down somewhere, an equation that you need to memorize for equation of a circle. So if we have h is 0, x minus 0 is just going to be x squared. And k is 4, so it's going to be y minus 4 quantity squared equals r squared. Now, if we look at our answers, we can eliminate some without even knowing how to get the radius. So we go over here. When you have a center, it's always going to be subtracted. So it's going to be not this one, and it's not going to be this one, because the equation is subtracted. Now, if this would have been a -4, it would have been a +4, but it's not. Now, the harder part of this problem is finding out the radius. One way you can do it, this is long. I would plot the point. The point is the center is 0, 4. So the center is right here, 1, 2, 3, 4. Then the end point is 4/3 and 5. So this is going to be 1, 2. So 4/3 is 1/3 that way, and then 5. Okay, so this is hard. Okay, so that's the radius of the circle. Now, if I made a right triangle, because we want to figure out what this r is right here. If I made a right triangle like this distance, I didn't quite come out far enough, it should be 4/3, is 4/3. This distance from 4 to 5 is 1. So if I use the Pythagorean theorem, I can figure out what the radius is. So it would be 4/3, told you this was hard, squared plus 1 squared equals the radius squared. So I'm going to get 16/9. I'm just going to change 1 into 9/9 equals the radius squared. And so the radius squared is going to be 25/9. And that's what the equation of a circle is, r squared. So r squared is 25/9, so this is your answer. Yikes. I would have probably picked that one because these are perfect squares. Not that these couldn't have been radical squared, but the perfect square kind of gives it away. That was hard. Yeah. Now those that have had this before might have gotten this, but if you never had it, it would be really hard to get that one right. Okay, the equation above expresses the approximate height in meters of a ball t seconds after it's launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? Well, the height would be 0 when it hits the ground. So I'm going to put a 0 in for hitting the ground. And I'm just going to solve, this is a quadratic equation. That's the tricky part, I think, is knowing that it hits the height would be 0. And I'm going to solve this. I'm going to take out a t. So I'm going to get negative 4.9 t plus 25. I'm going to set each of these two factors equal to 0, so I'm going to get t equals 0. Well, when time equals 0, that's when the ball started from the ground, and there's where it ended. So time is 0 is when it first was on the ground, and our next time is going to be when it hits the ground again. So we get negative 4.9 t plus 25 equals 0. Negative 4.9 t equals negative 25. Fortunately, we can use our calculators. So we put it into our calculator, and we get t equals 5.1, which happens to be close to an answer of 5. And that is how you do that one. All right, let's move back up here. I need more space. Katrina is a botanist studying the production of pears by two types of pear trees. She noticed that type A trees produced 20% more pears than type B trees did. Based on Katrina's observation, if type A trees produced 144 pears, how many pears did the type B tree produce? Okay, two different ways you can do this. It says here that type A trees produce 20% more than type B trees. They want to know how many type B trees, how many pairs of type B trees produce. Well, A trees produce 20% more. So if we look at our answers here, and we figure out what 20% more of these, which one gives us 144, we can get our answer. So we can do this without using any real algebra. So if we just pick an answer like, I'm just going to go with the right one and show you how it works. So if we have 120, and then we figure out 20% of 120, so I'm going to do that in my calculator right now, times 0.2, it's going to be 24. So 20% of 24, 20% of 24 is going to, of 120, do the answer right, of 120 is going to be 24. So if we added 24 to this, we're going to get 144. So that's totally without doing any algebra, it's just working from the answer. We know that type B trees produced 20% more, so we just figured out 20%, added it together, and we figured out what type A trees would be. Yeah. Type A produced 20% more than B. So this is just working from the answer. If you really want to know the algebra, I did it. Type A equals type B plus 20% of type B, and I just put the numbers in here. So that would be 144 equals, this is B 1.2 times B. If we add those together, we would get B equals 120. So keep in mind, even if you don't know how to do the algebra, you can often work from the answers to figure out what 20% more of this would be, and that would be your type A tree. Okay, let's do the next one. A square field measured 10 inches by 10 inches, each meters by 10 meters, 10 students, each mark off a randomly selected region of the field. Each region is square. Each region is square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters? So it's the same here, 5 centimeters, 5 centimeters. The depth has not changed of the ground surface in the entire area of the field. Okay, so the entire area of the field, I don't know if I can show this very well or not, is 10 by 10. Each student's plot is 1 by 1. So there's 10 students that have 1 by 1 plots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each student has a 1 by 1 plot. Now if I take all these numbers and I add them up, they're 1 by 1 plots, we're going to get 1,471. And you can see the numbers, they rounded it to 1,500 here. All right, that's this area. Each student's plot is 1 by 1. Well, the whole area is 10 by 10, so we're just going to multiply that by 10, and we're going to get 15,000. Because of each, instead of it being this whole area is 100, the whole big thing is 100 square meters, while this whole area is just going to be 10 square meters, right? This whole area is 10 meters squared. So to get from 10 to 100, we just multiply it by 10. We take our answer and we multiply it by 10, and we get 1,500. All right, next word. Okay, this is not this last page here. That's not the right word. So hold on a second, see if we can find it. 30, looks like I don't have that one. So I'm going to end the video right there with number 26.